In the last section, we started talking about half reactions for redox reactions. We said oxidation was the loss of electrons, reduction was the gain. Now, when we've got a reaction like this one, it's really easy, it's really nice. But sometimes we're going to have redox reactions that involve oxygen, and that makes it a little bit tricky. There are two types of redox reactions that are a little bit more complex. One is acidic solutions, and one is basic solutions. Now there's the same basic kind of steps, they just look a little bit different. So just like I did before, I'm going to write my separate equations, one for oxidation, one for reduction. Okay? Now, just like I did before, I'm going to balance my elements, but I'm going to ignore oxygen and hydrogen. I'm going to do those in a little bit. After everything except for oxygen and hydrogen are balanced, I'm going to look at oxygen. Now I'm going to have oxygens on one side but not the other, and so I'm going to use water to balance that out. The problem is, by adding water, I'm going to have hydrogen ions that don't, H's that don't balance out, hydrogens that don't balance out. So I'm going to add H pluses to the other side to balance them out. I know it seems kind of weird right now. We're going to go through several steps with a couple examples and you'll see how it works. The last thing I'm going to do is I'm going to make sure that my electrons are balanced. Okay? So I did that before. I had 1 electron, 2 electrons. I made sure that those canceled out and they were the same. Now, what's going to happen is when I do this, I need to make sure that my electrons are going to be balanced. So I may have to use integers to balance that out. Okay. And then I'm going to cancel out identical species. And I'm going to check and make sure that all of the elements and charges are balanced. Sounds really weird. I'll show you a couple of times. It's not that bad. Okay? Here it is in chart form. It got kind of fuzzy. Don't worry about that. It's just basically what we just said. So here's my redox reaction, and I'm told that it is an acidic solution. So I need to write my two half reactions. Well, iron's going to be pretty easy. Iron starts as a 2+, and it's becoming a 3+. I know that to go from a 2 to a 3, I need 1 electron, and it's going to lose that electron. MnO4, O is a -2. I've got 4 of them, so I've got 8 negatives. I know that the whole thing overall is going to be a -1, so I need 7 positives. Mn starts at a +7, it ends at a +2. So it has to change by 5 electrons. +7 to +2, it is going to gain those electrons. So iron is being oxidized. MnO4 is being reduced. Okay? So here's the way I'm going to write this. MnO4 minus is gaining electrons, so they are reactants. It's making Mn2+. Iron is starting as a 2+, it's becoming iron 3+, and it's losing 1 electron. Okay? Now when I look at this, I need to make sure everybody's balanced and everybody's happy that is not an oxygen or a hydrogen. 1 Mn, 1 Mn, that's good. 1 Fe, 1 Fe, that's good. Now I need to balance oxygens. I've got oxygens on this side, not on this side. So I need oxygens over here. I need 4 of them. I balance oxygens by adding H2O, and because I need 4 oxygens, I need 4 waters. Great. Now my oxygens are fixed. But by adding water, now I have these H's that I don't have over here. So I'm going to add H's over here. They're going to be ions, and I'm going to have 8 of them. Okay? So now all of my elements are balanced. My oxygens, my hydrogens, everything's good. I need to make sure that my electrons are balanced. So what I'm going to do now is I'm going to multiply this one by 5. I have 5 electrons over here, so I need 5 electrons over here. Has to be the whole thing. So when I do this, I'm going to have 5 Fe2 plus, 5 Fe3 plus, and 5 electrons. Anything that's the same on the left or the right, I cancel out. So my electrons are going to be gone, because remember, this becomes a 5, this becomes a 5, and that becomes a 5. And then I'm going to combine everything. So I'm going to have 8 H plus ions plus MnO4 minus plus 5 Fe2 plus. That's going to form Mn2 plus 5 Fe3 plus and 4 H2O. So this is my complete balanced redox reaction in acidic water. Okay? This 8H plus is what makes it an acidic solution. Okay? So let's take a look at the second reaction here. Cr2O7 minus C2H5OH forms Cr3 and CO2. So if I look at this, my Cr is here, it's changing into this. So let's look. Cr is partnered with O. I know O is a -2. I have 7 of them, so that's 14 negatives. When I'm done, I have to have 2 negatives. So 14 negatives plus 12 positives will be -2. Well, I know I need 12 positives. I have 2 CRs to get there, so each CR has to be a +6. So my CR is going from a +6 to a +3. It's going to be changing 3 electrons, and because it's becoming more negative, it's going to gain them. CR is being reduced. Okay? Carbon here is changing into carbon here. Well, if I look over here, oxygen's a -2. I've got 6 hydrogens. Hydrogen's always a +1 unless it's partnered with a metal. So I've got 6 positives, 2 negatives. So I've got 4 positives. I need 4 negatives to balance that out. I've got 2 carbons to do it, so each one's going to be a -2. CO2, oxygens are still -2. I've got 2 of them. 2 times 2 is 4. So I need 4 positives to cancel them out. So carbon is going from a -2 to a +4. So it's going to actually change by 6 electrons. It's going to lose 6 electrons to become more positive. Okay? So now I need to build my 2 equations. As I'm building my equations, Cr2O7, 2 negative, is going to gain 3 electrons. So those 3 electrons are going to be reactants. It's forming Cr3+. Okay? C2H5OH is going to lose 6 electrons. So those 6 electrons are going to be products, and it's going to form CO2. Okay? Now I start by balancing my elements other than hydrogen or oxygen. 2 CRs, 1 CR. I need to multiply that by 2. 2 Cs, 1 C. I need to multiply that by 2. Everything except O's and H's are balanced. Okay? Now I've got oxygens on this side, not on this side. I need to add water. 7 O's here, so I need 7 O's there. By adding water, now I have H's on this side, but not on this side. I have 14 H's here, so I need 14 H's here. Okay. The second problem is a little trickier because now I've got O's and H's on different sides. Okay, so this gets a little bit trickier. But if I look, start with my O's. 1 O here, 1 O here, 1 O here, 2 O's here, times 2 is 4. So I need 3 more O's. 3, 4, 4. Okay? Now I have to keep track of my H's. I've got 5 H's here, plus 1 makes 6. 3 times 2 is 6, so I've got 12 H's. I need to put them on this side. Okay. Now, I need to keep track of electrons. 6 here, 3 there. I need to multiply all of this by 2. So instead of 14, I'll have 28. I'll have 2 here, 6 here, 4 there, 14 here. Okay. Anything that's the same left and right, I cancel out. 6 electrons here go away. 6 electrons here go away. I've got 12 H pluses here, 28 here. All 12 of those go away. I'll have 16 left. I have 14 waters here, only 3 here. All 3 of those go away. I'm left with 11. So when I balance this, I'll have 16 H plus, 2 Cr2O7, C2 H5OH. It's going to form 4 Cr3 plus. It's going to form 11 waters. Water. And 2 CO2. Okay? So I'm going to follow these steps anytime I have an acidic half reaction. Basic reactions will be different. This is what I'm going to do for acidic.